Okay. Good evening. Good evening, all. Can you hear me? Everything okay? Abir, is everything okay? Okay. Uh, Last day we discussed about we start the heat lesson. Uh, okay, what's the meaning of heat? What's the meaning of heat? The basic, the heat. Yeah, quickly, I will give you 10 minutes to refresh last day lesson. What's the meaning of heat? Heat. Yeah, heat is a energy type, as I told, like magnetic energy, like current energy, electric energy, chemical energy. Yeah, heat is an energy type due to temperature difference. Good. The heat is energy type formed due to temperature difference. I told the heat is always transferred from high temperature to low temperature, from sun to earth, from fire to whatever environment. Fire, from fire to environment. Okay, heat is always transferred from high temperature to low temperature. High temperature to low temperature. The heat is energy type which is formed due to temperature difference. If there are no any temperature difference, I told no any heat energy formation. Okay, now I told the temperature. What's the temperature? The temperature is a measure of heat energy. That's the temperature is not the energy type. The heat is the energy type. The temperature is if any object has more energy, heat energy, its temperature is increased. Its temperature is high. The reason when increase the heat energy, the molecule I told you last day, when increase the heat energy of any matter, their energy level is increasing. Their energy level increasing means their kinetic energy. That means their vibrations increasing. When their vibrations increasing, their temperature is gradually increasing. Actually their vibration increasing means the temperature increasing. Okay, that's the temperature is a measure about the heat energy. The temperature and heat, it is not same, it is two different things. The heat is the energy type, heat unit is joule, temperature units are Celsius, Fahrenheit, Kelvin. Among that, the standard unit of the temperature is a Kelvin. The standard unit is Kelvin. Okay, last day I told in this lesson we mainly discussing about three main areas. What are the areas? This lesson, the heat lesson, we can divide into three parts. The first one is thermal expansion. The second one is quantity of heat, and third one is thermal transformation, isn't it? Uh, Thermal expansion, quantity of heat, and finally, oh, give me a second. There are 25 student message. Okay, sorry. These days 25 student more stress period because they have only 2 months to exam. Now 25, if you go to our YouTube channel or our website, in 25 class, now we are doing uh, perfect revision program. We doing 3 days per week, 3 days per week for 25 students. uh, for you also, when close to exam, we increase the workload. Every type of papers we doing in the revision, model papers, past papers, and every up to now in revision, last 6 months we did one exam per 1 month. Now within this final 3 months they have 2 exam per month, 2 exam per month, and finally they are 5-hour exams. 5-hour exams. They are not like your exam. They are exam level, A level questions. New questions, not past paper questions. Exams are going with new questions. And we also discussing past paper questions as well. Past paper questions, actually you also can do with, you have past paper and you have mark scheme, then you can try. In our target is more than past papers, try more new questions in the revision. Okay, what we discussed? Heat energy. In heat lesson, mainly three part we discussing: the thermal expansion, quantity of heat, and thermal transformation. Okay, then last day we start the thermal expansion. Okay, how any object is expand? Can you explain how any object is expanded? What's the meaning of thermal expansion before that? What's the meaning of thermal expansion, Fatima? What's the meaning of thermal expansion? What's the meaning of thermal expansion? What? Thermal expansion. Very good, Rehlan. Very good, Fatima. When increase the temperature of any matter or object, its size or volume increasing, that we called as a very good, Sandeep. Yeah, increase the size or volume increase, that we called as a thermal expansion. Thermal expansion, how it is happening in any matter? Normally there are three matter types we discussed last day: solid, liquid, and gases. Solid, liquid, and gases, there are three matter types. Every matters are, what are the building blocks? Molecules, atoms. Atoms are the building blocks. Every molecule, their building blocks are atoms. Then according in their structure, when increase the temperature, what happened? What happened when increase the temperature? These lessons, this lesson try to get maximum within the class. Okay, they are very practical, interesting lessons. Now, not like actually more than initial part of our syllabus, the middle part is very interesting. The heat lesson, thermal chemistry, the next part lessons are very interesting. Therefore, try to get maximum within the class. Now you have 3 hours. Within these 3 hours, try to get maximum advantage, maximum knowledge and understanding. Then you know, don't need to extra works. You only need to in other days, you only need to refer, get some small time and refer on this, go through this. Okay, therefore they are practical, you can understand. The every matter is expanding, I told. Every matter is expanding. How it is expanding? How it is expanding? When increase the temperature, their kinetic energy increasing. Kinetic energy increasing means their vibration increase. To vibrate more, they need more space. They need more space. Therefore, their intermolecular spaces is increasing. Their intermolecular spaces, the space space around it, space around molecule is increasing. The intermolecular space is increasing. Intermolecular space is increasing. Intermolecular space increasing, its volume automatically increasing. Okay, I told solid, liquid, and gas, every matters are expanding. Every matter is expanding. Okay, which one has more capability to expand? Which one has? Very good. Others? Amina? Gases, very good. Gases, because gases has weak bonds, and they have more spaces. They have more spaces. Therefore, when increase the temperature, the gas expand more than solid. Okay, I'll explain example. If you keep a balloon ball filled with gas, balloon ball filled with gas, and place in sunlight, in hot sunlight, what happened? Look at the wind. With sunlight, what happened when increase the temperature? What happened practically? I asked him what happened after when increase in temperature inside the balloon. No, nothing. You can test. මේ බැලුන් එක කවුවේ තියුවම මොකද වෙන්නේ? Yeah, blast. It is blasting. It's blast. After some moment, balloon will blast. Yes, balloon will blast. After some moment, yes. After some moment, make up it is fully filled with gases. Make a ගොඩාක්ම fill කරන්න ඕනේ. නැත්තම් පුරන්නේ නැහැ. Okay, fully filled with gases and place in sunlight. When heating, it is blast. Okay, what is the reason? What's the reason? Now you know the layer of the balloon. The layer of the balloon is a solid. It is a solid. It's a solid. Inside this solid layer, this is gas. This is gas. Okay, now what happened? When increase the temperature, the balloon volume is increasing. It is solid expansion. The balloon volume is increasing. With same temperature, the gas also expanding. You already know more than solid, the gas expand ability is higher. The expand capability is higher than solid. Therefore, gas is expand than the solid. That's why it is plus. I got the point? Solid layer එකට වඩා gas එක expand වෙනවා. Then what happened? The volume inside the balloon is not enough for this gases. That's why it's become plus. Understood? The gases has more capability to expand than solid and liquid. When we compare solid and liquid has more capability to expand due to their low strong bonds. I got the point? Yes or no? I got. Amina, I got. Okay. I think you all registered on website and you can order. If you paid for last month, you can order last month course page. If you paid for this month, you can order this month course page. Okay, I think all registered, no? Anyone not registered? All registered. All registered, no? Okay, actually, I can't find who registered and who not registered. I don't have access towards them. I have the total number of registration I have. It is now 105, I think. More than 100 now registered. Okay. The heat, when increase the temperature, it's the kinetic energy vibration increasing. Therefore, there are spaces increasing inside, between molecule spaces increase, intermolecule spaces increase. Therefore, their volume is increasing. That's the expansion. I told solid, liquid, gas, and every matters are expanding more than solid. Liquid expansion ability is higher. More than solid and liquid, the gas expansion ability is greater. Okay, now according to the matter type, I think you can remember, according to the matter type, expansion, according to the matter type, expansion, we can divide into three types. How we divide? What are the three types? Now, still we are last day lesson. Sandra, you join, no? Sandra, still we are refreshing last day lesson. What are the three main expansion types according to the matter type? I need to answer now. I am asking last day lessons. Who? Rehlan? No. In this lesson, I'm not asking this one, Sandhi. It is in our lesson. Now we are in the thermal expansion. Sorry, this topic is wrong. No? Thermal expansion. Thermal expansion. Thermal expansion. According to the matter type, they mainly three types. According to matter type, mainly three types. Yes. Solid expansion, liquid expansion, and gas expansion. Okay, last day start the solid expansion. Solid expansion mean very simple. When increase the temperature, solid object volume or size increasing. That's a solid expansion. Okay, now solid expansion again. How many types? Three types. I think you can remember. Solid expansion again, three types. Solid expansion we can divide into three types: linear expansion, area expansion, volume expansion. Linear expansion, area expansion, volume expansion. Volume expansion, this is the expansion classification. Expansion, full expansion, expansion classification. Solid expansion, liquid expansion, and gas expansion. Solid expansion again three types: linear expansion, area expansion, and volume expansion. Okay, next. Last day we did linear expansion. Okay, linear expansion mean how you can linear expansion. Okay, that's only we discussed, no? That's only we completed. Okay, I will quickly explain the linear expansion and go to the today lesson. But how we define the linear expansion? Now, this lesson is actually very simple. If you remember one definition, everywhere you can apply the same one. when temperature increase, the length or height of any solid object increasing, that we called as in a one dimension. Yes, one dimension. Only we consider about one dimension, not two. If we only length or height, we discuss it. Okay, when increase temperature, length or height in a one dimension increase, that we called as a linear expansion. Linear expansion, there are three main factors affect on the linear expansion, as I explained last day. What are the factors? What are the factors? What are the factors? Initial length, temperature difference, and substance type. Substance type means material type. Substance or material type. Very good. Okay, now think this is the L1. Think this is the L1. Think this is the L1. This is the L2 final length. I think you can familiar this. Now you are familiar these letters. And this increasing length that we called as a delta L. This length, the increasing length due to temperature difference, that we called as a delta L. The delta L is the linear expansion. I told the delta L is the linear expansion. Now this one theta 1 temperature, this one theta 2 temperature, theta 2 minus theta 1 is the temperature difference, delta theta. Delta theta. Okay, remember delta theta 2 minus theta 1 is the delta theta. Delta theta. Temperature difference. Okay, there are three main factors. The first one is the initial length, temperature difference, and material type. The first one, when increase the temperature difference, I told, when increase the temperature difference, the linear expansion delta L is increasing. When increase the temperature difference, delta L is increasing. When increase the temperature difference, delta theta directly proportional to the delta L. Okay, opposite guys. Delta L directly proportional to the delta theta. Last day lesson I am explaining. The second one, when increase the L1, the initial length, L1 also directly proportional to the delta. Sorry, yeah. Delta L directly proportional to the L1. Okay, now you have two relations, then we can get the final equation. Finally, we can get the delta L equal L1 alpha delta theta. Delta L equal, to remove this proportional mark, I use a special symbol that we called as alpha. That we called as alpha. That we called as alpha. What's the name of this alpha? What's the name of this alpha? Name. What's the name of this alpha? No. Kabir. Not the thermal expansion coefficient. Coefficient of linear expansion. Very good. Or linear expansion coefficient. Kabir එහෙමද ලියලා තියෙන්නේ? හදාගන්න. Yeah, coefficient of linear expansion. Linear expansion coefficient. 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 The alpha is the linear expansion coefficient. Okay, this equation, I told there are three main factors affect on the linear expansion. The first one, initial length, temperature difference. Initial length, okay. Initial length, okay. Initial length, okay. L1. The temperature difference also okay. What is the other factor? Other factor is the alpha. That's a factor. The alpha is the linear expansion coefficient. This is a factor depend on the material type. That's why we call there are three main factors. When change the matter types, the alpha value is changing. As example, for copper, there is a specific alpha value. For aluminium, specific alpha value. For iron, specific alpha value. For lead, specific alpha value. Okay, linear expansion value. When change the matter type, that is changing. Okay, that's why we call there are three main factors. Now you can understand the initial length, matter type, and the temperature difference. Initial length, matter type, and temperature difference. The alpha is a linear expansion coefficient that's depend on the material type. That's actually constant depend on the material type. It is changed according to material only. Material එක වෙනස් වුණොත් විතරයි වෙනස් වෙන්නේ. For as example, if you got different aluminium cubes, different shape, its alpha value is same because matter type is same. Okay, that we can discuss in the calculations. Okay, that's the summary. Then I told if I'm going to erase this part. Okay, that's our equation that only we need. Okay, I told if I isolate the alpha, okay, can you define the alpha? How we define the alpha? It is important. Now, know anything to remember again. Now, alpha definition is the most difficult definition I given. Alpha, the linear expansion coefficient, how we define? Are you typing? Okay, can't remember. Yes, very good. When increase the temperature. Now you can actually, you don't need to remember. If you understand it, that enough. Okay, think the same equation. If I isolate the alpha, what is the equation? Make a isolate, take a separate karo. If I separate the alpha from this equation, then delta L, this is physics, okay? Delta L, don't need to actually, only very few concept only you need to remember. Okay, the definitions, no need actually. If you can remember, if you can understand like this, that enough. You can see if you isolate the alpha, delta L over L1 over, sorry, L1 into delta theta, no? Then you already know this type equation, the below factors become to 1. Below factors, they are 1. As example, the velocity equal displacement over time. Displacement over time. Then what's the meaning of the velocity? The displacement within unit time. 1. Displacement over unit time, that we called as velocity. Same. Okay, then how we define the linear expansion coefficient? The linear expansion coefficient is when increase the temperature by 1 degree of unit length of any matter. When increase the temperature of unit length of any matter, the linear expansion, the length increasing amount, delta L, we called as alpha. Understood? Any doubt in linear expansion, you can ask. Now we go into calculation. That's why I'm explaining again. Okay, if you understood, that's in second time I am explaining. If you understood this linear expansion, other area expansion, volume expansion, very simple. Only I need to guide you. You can continue. Okay, any doubt? Please ask. Any doubt? Okay. Do you remember what is the unit of linear expansion coefficient? Alpha unit? Alpha unit? Alpha unit? Alpha unit? Alpha unit, you can, no need to remember. See, the delta L unit is meter, standard unit. Length difference, L1 unit also meter, length, initial length. The temperature difference, standard unit is Kelvin. Now meter to meter cancel out, Kelvin come to up. Then per Kelvin is the unit. Per Kelvin is the unit. Per Kelvin. Kelvin per Kelvin. Kelvin minus 1. Per Kelvin is the unit. Per Kelvin is the unit. Okay. Final point. Okay. Now we discussed everything last week lesson. Everything last week lesson. Okay. Finally, Kabir, have we discussed the L2 equation as well? Oh, up to now only. L2 final length equation also we discussed, no? Oh. Okay, then the linear expansion completed. Then we can get the, this is delta L, no? The linear expansion, increase in length. Using the same equation, we can get another equation to get the final length, L2, after temperature difference, final length of the rope. Okay, actually this equation don't need, if you know this one. Okay, now you can say the L2 equal delta L2 equal L1 plus delta L. L1 initial length. What happened? What happened to the L2? Wait, mistake. Okay, sorry. Now L2 equal L1 plus delta L, no? Delta L. Initial length plus increase in length. Initial length plus increase in length. Then we can get the L1 instead of this delta L. We can, if you want, you can substitute this part. Then L1 plus L1 alpha delta theta. L1 alpha delta theta. Now L1, sorry, L2. L2 equal, L1 is common for both. Now you can get out. Now 1 plus alpha delta theta. Okay, now you have three equations. This is your first equation. This is your second equation if you want. This is your third equation, but this equation is important. They are not equations, very simple relationships, no? Relationships. Okay, that's all about linear expansion. Now we go into calculations. Any doubt? Okay, if anyone not don't know last week lesson, now you can engage with the lesson. Now that's the last day lesson actually. Last day 3 hours lesson I explained within 20 minutes. Okay, any doubt? Everything understood? Everything understood? Yes or no? I don't know. Understood or not? Okay, there is a problem with. Okay, give me 1 minute. Have my board don't have the PDF. I will upload the board. Give me 1 minute, and you can try the first question. Now you already have in class exercise tute, not tute paper. Okay, please go through this. Question number 1. Okay, I try these questions in the home. The linear expansion question. I complete. Okay, it has the numbers wrong. 2, main 4 questions. Okay, if not, no problem. Okay, they are in class questions. Okay, go complete the question number 1. I can give you 1 minute. Question number 1. An aluminium rod is 4 meters long at 20 Celsius. 20 Celsius. If the linear expansion coefficient of the aluminium is given, calculate the length of the aluminium at 80 Celsius. Calculate the length of aluminium at 80 Celsius. Okay, what you got the answers? If you got, you can send the length of the aluminium rod at 80 Celsius. Okay, I'll explain this first question. Okay, there is a aluminium rod. Its length is 4 meter at 20 Celsius. At 20 Celsius. 20 Celsius. Its length is 4 meter. 4 meter at 20 Celsius. The question asks, at 80 Celsius, what is the length? The L2 is asking. The L2 is asking. Okay, we have two options. I will explain both method. Okay, you have two options. The first method is you can find the delta L. What is clear or not? Clear on Fatima? Is both clear? I think in my side there is a Sandeep. Is it clear? These values? Clear, no? No, in my side, I think. Okay, now good. Okay, it is 80 Celsius. Uh, the question asks L2 actually, the final length. The question asks final length, but you can directly L2 equation. Oh, you can first calculate the delta L and next go to the L2. No problem. Okay, both method correct. Okay, if you can't do advanced calculation, you can first calculate the delta L. The delta L equal L1 alpha delta theta. The delta L we don't know. L1 is 4 meters. The alpha value is given in the question. 20 into 10 to the power minus 6. 20 into 10 to the power minus 6 per Kelvin multiplied by temperature difference. Temperature difference 80 minus 60. Theta 2 minus theta 1. 80 minus 20, it is 60. 60 Kelvin you can use because of temperature difference. Now you can see Kelvin to Kelvin minus 1 cancel out. Kelvin to Kelvin minus 1 cancel out. Now 4 multiplied by 20, it is, yeah, before that 20 multiplied by 60, it is 1200, no? 1200 multiplied by 4. You can use calculator. 20 into 60, it is 1200. 1200 multiplied by 4. 48, 20, 4800. 4800. Now 4800 multiplied by 10 to the power minus 6. 10 to the power minus 6. 10 to the power minus 6. Now 10 to the power minus 6, then you can get the 1, 2, 3, 4, 0.0048 meter is the answer. 0.0048. 0.0048. 0.0048 meter is the delta L, but the question not asking delta L, the question asking L2. The question asking L2, therefore L2 equal L1 plus delta L. L1 plus delta L. Question asking L1 plus delta L, then the L1 you already know 4 meters. 4 meters plus 0.0048 meters. 4.0048 meters. That's the Celsius. 80 Celsius. This is the length. 80 Celsius is the length. Understood? Fatima, are you correct? Amina? Dihini? Sania, could you get this? Good. Okay, now the second part is little confused, I think. Okay. The same question, I will explain how to get by second equation. Next one, okay. Rehlan, what happened? Rehlan? Is in S. Rehlan, are you there? Okay, okay. Okay, now this is the general method. Now, if you want, you can use directly L2 equation we have. If you want, you can use directly this one, this L2 equation. Can I erase this? Can I erase? I'm going to erase. I think you can do this. Yeah. Second one minus 40. Minus 40. Then temperature decreasing. Then length increasing or decreasing. The length decreasing. The length decreasing. Okay. Before going to second one, I will explain the same question how we doing in second method. Second method. Okay. I'm not going to every questions by both method. Only first question I will show you. Okay. Now L2 equal. We have another equation. L2 equal L1 1 plus alpha delta theta. Now the L2 you can get directly. The L1 is 4 meters. 1 plus alpha is 20 into 10 to the power minus 6 into delta theta is 60 Kelvin. It is per Kelvin. It is cancel out. It is cancel out. Okay, now this calculation you need to know. 4 into 1 mean 4. 4 plus these all are multiplications. Then 20 into 60 into it is 4,800. No, 4,800 into 10 to the power minus 6. It's meter. Now 4 meter plus the same method, same answer is coming. 0.0048 meter. Then 4.0048 meter. This is a second method. Good, Sanwar. Okay, this is not second part. The first question I explained in second method. Okay, you don't need to do both methods. One method is enough. Okay, any doubt? No doubts, no? Okay, go to the second one. The question asks, same rod, calculate the length of the aluminium rod at minus 40 Celsius. Now the temperature increasing or decreasing? The temperature decreasing. The temperature drop. The temperature drop means the length increasing or decreasing? The length is decreasing. The length is decreasing. The length is decreasing. Okay, I'm going to erase. Okay, now better this for this one, better to use the delta L equation is easy. L1 alpha delta theta. The L1 is 4 meters. Alpha is 20 into same rod 10 to the power minus 6 per Kelvin. Now it is 20. Now think this one is the 20. This one is the 20. This is the 20 Celsius. Its temperature decreases up to minus 40. Then how about the temperature difference? How about the temperature difference? Minus 40 to 10, 20, 20. Minus 40 to 20. How about the temperature difference? Yeah, no any answers. I think all are calculated. Only send me temperature difference and doing calculation. Okay, if you got, is it 20? 40 to, sorry, 20 to 40, is it 20? Temperature difference? No, no, minus 20 is not the temperature difference. Now you have to think in heat. No, no, wrong. No, no, I'm asking, Rehlan, what is the value of temperature difference? Very good, Fatima. Temperature difference, no? Your value is correct. No need minus value. Minus no need. Minus no need. Get as a only different. Okay, now first think 40 to increase up to 20. Then 40. First of all, we need to convert into 0. Then how many temperature? 40 Celsius difference. Then after that again increase up to 20. Think minus 42. First increase up to 0 Celsius. Then finally increase up to 20 Celsius. Then how many difference between that? You have to think in heat, not values. The heat concept dala hitanda. The minus 42, it's come to 20. It's Then first of all, the gap is, this gap is 40, this gap is 20, then altogether 60. 60 temperature difference. Sanura, what you got? Temperature difference? Okay, minus 60 or 60 you need to get. Minus don't need. 60, 60. Now the temperature difference is 60 Kelvin. Then Kelvin minus 1 to Kelvin cancel. Now same answer. Same answer. 0.0048 meter. Now this amount is decreasing, not increasing. Therefore, this is not the plus, it is subtract. Subtract. Only subtract. The symbol is changing. Subtract. Then 3 point, what's the value? 3.9952. Very good. 9952. 3.9952 meters. Any doubt? Please ask. Do it have a limit? Do it have a limit when it comes to the decreasement of length? Limit mean Rehla? Sanura? Yeah, temperature decrease, correct. The length decreasing. Is there a limit? Good question. Can you understand? Actually, second part you can understand. It is its limit actually is they are melting and boiling point. I think still you can't understand this much level. Okay, think about water. Water. The expanding limit is the 100 Celsius. Up to 100 Celsius, it is expanding. That means their physical state change when come. Until their physical state is changed, their space is increasing and decreasing. Okay, that we can discuss in the next part, Sandra. In physical quantity of heat part, we broadly discuss this part. Okay, now only we discussing when temperature increase, its volume increasing. Okay, but when increase the gradually temperature after certain level, its physical state is changing. The reason is the vibrations increasing, continuous increasing. They cannot tolerate that. Due to can't tolerate, their bonds break down or new bonds formation. Therefore, their physical state is changing. As example, if you go to an ice cube, if you get ice cube, it's expand up to 0 Celsius. Melting point. After melting point, as solid, it cannot again expand. Therefore, their bond break down. As a solid has strong bonds. No, solid has strong bonds. Their bond, some part of bond break down, and it's converted to liquid. Then liquid expand. Understood, son? that we can discuss full uh, in second part. Okay, good question. Okay, can you give to the second question? Okay, I will complete few question and others I will go give you as a homework question. Okay, quickly calculate this one. Okay, get the values. Yes. Okay, what is the question 2 asking? Find the a new radius of a circular plate of radius 50 centimeter when the temperature is increased by 20 Celsius. By 20 Celsius. By 20 Celsius means temperature difference is 20 Celsius. Temperature difference 20 Celsius. The linear expansion coefficient of the copper is given. It's a copper plate. Copper plate. Initially, the radius is 50 centimeter. The temperature increased by 20 Celsius. New radius is asking. Then L2. L2. Same as previous. Same as previous. It is radius like a line. Take as a line. Radius. Take as a line. If you want it, you have a long method. You can get the circumference and calculate the circumference and again get the radius. Don't need. You can get that as 50 centimeters. No, 50 centimeters. Yes, 50 centimeters. The delta L equal L1 alpha delta theta. 50 centimeter. Do we need to convert meter? No need, because it don't need the answer coming with centimeters. Answer coming with centimeter if you substitute in centimeter. If you substitute in meter, answer coming in meter. Okay. The alpha value given in the question, the alpha of the copper 17 into 7 into 10 to the power minus 6 multiplied by per Kelvin into delta theta, temperature difference by 20 Kelvin. Kelvin to Kelvin minus 1 cancel out. Kelvin to Kelvin minus 1 cancel out. 15 to 20. It is 1000, no? 1000 into 7, 17,000. 17,000. 17,000 into 10 to the power minus 6 centimeters. This is the value. Then 1, 2, 3, 4, 5, 0.017. 0.017 centimeters. It is centimeters. Okay, because I substituted from centimeters, the answer also comes in centimeters. Are you good? Okay, now 0.017 centimeters. Now the L2 is asking, the delta L is okay. The L2 is asking. The L2 is asking L1 plus delta L. Then 50 centimeters plus the delta L is 0.017. 50.017 centimeters. 50.017 centimeters. Very good, Sanura. Kabir correct. Dihini. Okay. You got from meters, no? You converted into meters, but not. It's not compulsory, Dihini. Now, however, it's correct. Fatima, I got. Do not send me the answer. Now you send. Okay. Amina, correct? Okay, now go to the third question. That's final question. Other questions are homework. You have to complete it, because now I am going to move into area expansion. This is a good question. Okay, you have to do within time. Okay, now you have a timer. I will give you 2 minutes. 2 minutes. Okay, now it's starting. Kabir, good, you got only 1 minute and 15 seconds. Fatima, 1 minute and 25 seconds. Dihini, 1 minute and 30 seconds. You have only 5 seconds. Okay, time over. Okay, how we get this? Then iron rod of initial length 120 centimeter, and when it is temperature increase from 0 to 100, the increased length is, that's mean L2 is 1.52 meter. 1.52 millimeters. Find the linear expansion coefficient of fire. No, L2, no, delta L is the 1.52 millimeter, no? Yeah, delta 0.52. Then I'll do here, the delta L equal L1 alpha delta theta. Now the delta L is given 1.52 millimeters, equal L1 is 120 millimeters. 120 millimeters. Don't need to worry about unit, because millimeter to millimeter cancel out. No, millimeter to millimeter cancel out. Multiply by the alpha, we don't know. Alpha we don't know. We finding alpha. The temperature difference is C 100 Kelvin. Now millimeter to millimeter cancel out. The alpha equal 1.52 divided by 120, 12,000. 12,000, no? Then very small value is coming. What is the answers? Yeah, 1.27. 1.27 into 10 to the power minus 5, no? Correct? Per Kelvin. Others correct? I only got your answer. One of your answer I got. Correct, no? All are same. Good. Correct. Okay. Are you clear linear expansion now? Linear expansion clear? Are you clear linear expansion? No doubts? No doubts, no? Okay, now come to area expansion. Okay, other two questions are homework. Okay, now you can do in your home. Okay, write down the topic, the area expansion. You can do this calculation in the book, okay, your book. Okay, you can keep spaces. It has same question B part, and there is another question, two questions. You can keep some space to do this calculation. Okay, keep 10 to 15 rows, that enough. 15 to 16 rows, that enough for this calculation. And write down the topic, the area expansion. The area expansion. area expansion. The area expansion. Okay, what is the meaning of this area expansion? The area expansion is very simple. Now we consider two dimensions. In linear expansion, we only consider one dimension. In linear expansion, sorry, area expansion, we considering two dimensions. Two dimensions like this. Two dimensions like this. Okay, like this. Now you can see this type object, it has a length and sorry, it has a length and a and width, length and width, two dimensions, length and width, two dimensions. Now considering two dimensions, when increasing the temperature, now think, understand, when increasing the temperature, okay, like this, when increasing the temperature, this is the initial length, this is the initial length at theta theta 1 temperature, think it is theta 1 temperature, this is theta 2. When increase the temperature, it's the surface area increase in two dimensions. Now in two dimensions, length and width both increase, in that we called as, you can see the length, the surface area increasing in both length and width both, two dimensions, that we called as a area expansion of solid expansion. Okay, when increase the temperature, the area of any object increasing with two dimensions, that we called as a area expansion. Okay, area expansion also, there are three main factors affecting. There are three main factors affect on the area expansion. There are three main factors affect on area expansion. There are three main factors affect on area expansion. There are three main factors. What are the factors? Remember that the first factor is the initial area. There are three main factors affect on the area expansion. The first one is the initial area. Initial area. Initial area. The initial area, the symbol is A1. Initial length is L1. This is A1, area 1. The second point is the temperature difference. Temperature difference. Temperature difference. Temperature difference delta theta. It is same as linear expansion. The third one is the matter type or substance types. Substance type. Substance type. Substance type. Substance type. Okay, that is the area expansion, same as linear expansion. The only difference in area expansion, it's increasing in two dimensions, length and width both. Okay, are you got the area expansion? Okay, write down the first point. When increase the substance of any solid object, when increase the temperature of, sorry, mistake, when increase the temperature of any solid object, when increase the temperature of any solid object, the surface area increasing, the surface area increasing, the surface area increasing from two dimensions, from two dimensions, from two dimensions, from two dimensions, within bracket length into width, within bracket length into width, called as area expansion, called as area expansion, called as area expansion. Denith, are you complete the note? Have you completed the note? You got the recording? Denith? Good. Okay, second point. There are three main factors. There are three main factors affect on the, there are three main factors affect on the area expansion. There are three main factors affect on the area expansion. Write down first one, initial area within bracket A1. Second one, temperature difference within bracket delta theta. Third one, substance type. Substance type don't need any symbol. I will explain later. Substance type or matter type. Substance type or matter type. Both same. Okay. Substance type or matter type. Substance type or matter type. Substance type or matter type. Okay. Now, what do you think? Now, stop writing. Now, what do you think when increase the initial area? That means A1. What do you think the linear expansion, area expansion? The area expansion means delta A. This delta A amount, this increasing area that we called as a delta A. This is delta A. This is delta A. Okay, what do you think when increase the initial area? What happened to this delta A? Initial area increasing. Very good. Now it is same as previous. Okay, no any difference actually. I am going to explain rapidly therefore. Now there are three main factors: initial area, temperature difference, and substance type. Okay, now when increase the temperature, when increase the initial length, initial area A1, the delta A is delta A. That's the area expansion. That's the area expansion. Okay, when increase the A1 initial area, give me 1 second. Okay, sorry. Okay, what I told, when increase the initial area increasing, A1 increasing, the delta A is, the area expansion is increasing. Area expansion is increasing. Therefore, we can say the delta A directly proportional to the A1, same as linear expansion. Now, when increase the temperature difference, what do you think? Temperature difference increase, delta A is increasing or decreasing? When increase the temperature difference, delta theta increase, what happened to the delta A? Delta A is same as linear expansion, increasing, very good, increasing. Now, the delta A, therefore, we can say the delta A and delta theta directly proportional. Delta theta directly proportional. Now, same as previous, we can say, according to this relationship, the delta A directly proportional to the A1 delta theta. A1 delta theta. Now I want to remove this proportional mark, same as linear expansion. I want to remove this proportional mark. Therefore, delta A change into equal. Proportional mark change into equal. Now the A1 to remove this proportional mark, I just do it to add what? The constant. The constant, remember, in area expansion, it is beta. It is beta, not alpha. Remember, this is the beta. The beta delta theta. Beta delta theta. Okay, now this is equation of the area expansion. Equation of the area expansion. Delta A equal A1 beta delta theta. Delta A equal A1 beta delta theta. Delta A equal A1 beta delta theta. What is the linear expansion coefficient? Delta L equal L1 alpha delta theta. Area expansion, delta A equal A1 beta delta theta. Okay, now, can you imagine what is the meaning of this A1? Sorry, A1, okay. The A1 is initial area, beta, sorry. Oh, I confused. What's the meaning of this beta? What's the meaning of this beta? Now, in linear expansion, what is the meaning of the alpha? It is linear expansion coefficient. Remember, the beta in area expansion, beta we called as the area expansion coefficient. Alpha is linear expansion coefficient. Beta is the area expansion coefficient. Are you got? That we can identify. This is area expansion coefficient. Area expansion coefficient. Are you got? Clear? Understood? Please respond. Fatima? Rehlan? Great. Okay, now this is the um, area expansion coefficient. Now, if you got the area expansion coefficient beta, how you can explain that? Area expansion coefficient beta. Area expansion coefficient beta. Area expansion coefficient beta. Now, okay, now I don't have space. Okay, first of all, note down this. Okay, draw this, and write down this relationship and note down this up to now. Note down, then I will explain. First, draw this. Okay, you already written these factors. Then below that, draw this diagram and write down this one and final equation. And name this. This is area expansion coefficient. The beta is the area expansion coefficient. If you complete, please let me know. Very good, Kabi. Yeah, this is the area expansion coefficient. Okay, very good. Okay, note down and let me know if you complete. I complete. Complete. And highlight the final equation. That's the basic equation of the area expansion. Others are formation of this. This is a basic one. Fatima, complete. Amina, Rehla. Done. Yeah, completed. Okay, now I will minimize them. Zoom out. Okay, now this is our final basic equation, delta A equal A1 beta delta theta. Now, if you got the beta, if you isolate the beta, how you can take this? The beta equal, beta isolated, the beta equal delta A over A1 delta theta. No? Okay, now same as linear expansion coefficient, can you define this? The samely the area expansion coefficient also it is a factor depend on the matter type. It is a factor depend on the matter type. That's why I told there are three main factors: initial length, sorry, initial area A1, the temperature difference delta theta, substance or matter type is the beta. The beta is a factor, the area expansion coefficient is a factor depend on the matter type. Okay, then how we can explain the, how we can define the beta? Can you define the beta? Very good, Kabir, correct? Okay, now it is very simple. When increase temperature by 1 degree of unit area of any substance or matter, when increase the temperature by 1 degree of unit area of any substance, the increasing area, when increase temperature of unit area of any substance, the area increasing, the area expansion, that we called as the area expansion coefficient. I got when increase the 1 degree of temperature of any matter unit area, that's in 1 square meter or 1 square centimeter, its area expanding amount that we called as a beta, area expansion coefficient of area expansion. Understood? Please send me yes or no, then we can quickly discuss. If you have any doubt, please quickly ask, then we can remain our time, because we have only 1 hour. Within 1 hour I need to complete this expansion full part. Expansion today we need to complete. Next week we start quantity of heat. Sarmya, welcome to 26th class. Yeah, what happened? Are you go through last day class? Could you understand? Good. Yeah. Okay. In this class, lot of students doing like you within 1 year. Okay. Then write down the, how about the unit of this beta? Unit, now the linear expansion alpha unit is per Kelvin. The alpha unit is per Kelvin. The alpha unit is per Kelvin. The beta unit, what is the beta unit? Very good. It's also per Kelvin. How it is coming per Kelvin, you can see the area expansion amount. What is the unit? Square meter. Square meter. The area, the initial area, square meter. Initial area also is square meter. It is per Kelvin. Then cancel out. The Kelvin go up. It is per Kelvin. Per Kelvin. The unit is per Kelvin. Therefore, area expansion and linear expansion unit is same. Both depend on the matter type. Both depend on the matter type. Both depend on the matter type. Okay, write down the subtopic, the area expansion coefficient. Write down the subtopic, the area expansion coefficient. Write down subtopic, the area expansion coefficient within bracket beta. The area expansion coefficient within bracket beta. The area expansion coefficient within bracket beta. Within bracket beta. Write down point 1. First point. The beta is a factor. Sorry, the beta is a constant. The beta is a constant. The beta is a constant that depend on the material type. Beta is a constant that depend on the material type. When change the material type, the beta value also change. The beta value also changing. The beta value also changing. Second point, write down with the star mark. Write down with red color star mark. When increase the temperature of, when increase the temperature by 1 degree, when increase the temperature by 1 degree of unit area of any substance, when increase the temperature by 1 degree of unit area of any substance, the area expansion amount, the area expansion amount of the substance, the area expansion amount of the substance called as the area expansion coefficient, called as the area expansion coefficient, called as the area expansion coefficient, called as the area expansion coefficient. Then write down the beta equation and make the unit standard unit Kelvin, standard unit per Kelvin. Complete. These two only you need, right? Dihini complete. Great. Okay, now there is another very important point we have to discuss. The always think we have aluminium rod. Aluminium rod. The aluminium rod, think its linear expansion coefficient. The alpha value is 5 into 10 to the power minus 5 per Kelvin is the alpha value. Okay, per Kelvin is the alpha value. Alpha value of this aluminium. Alpha of aluminium. The linear expansion coefficient of aluminium. Then the exam or any question, they not given beta values. Beta values. We have to find these beta values. Exam make it alpha value. So beta values. They in the exam only giving alpha values. Okay, now how we find the aluminium beta value, aluminium area expansion coefficient. The aluminium area expansion coefficient, the beta of aluminium, it is alpha of aluminium. The beta of aluminium, we can say it is 10 into 10 to the power minus 5. Now I think you can identify a relationship. You can get some relationship. Remember very well, the always the beta is equal to 2 alpha. This is the most important relationship because beta values, any question, any exam, not giving beta values. Only alpha values giving. Then you need to multiply this alpha value by 2 to convert into beta. Okay, write down special point below these equations. Write down a special point with again red color star mark with highlight. Always the beta value is equal to, always the beta value is equal to twice of alpha value. Twice of alpha value. Twice of alpha value. That's been multiplied by 2. Okay, then write down beta equal to alpha and highlight. Beta equal to alpha and highlight. Okay, final point. Are you got up to now? And are you clear up to now? Don't keep any doubt points. Okay, try to get 100% idea of them. All are same order. Same order, only one point is new. The beta equal to alpha, that's only new point. Other all are same as linear expansion. Correct? Clear? Good. Then in exam only giving alpha value, by multiplying by 2, you can convert it to beta. The beta is the coefficient of area expansion, alpha is the coefficient of linear expansion. Good. Okay, now uh, write down subtopic. Prepare a relationship. Prepare a relationship. Prepare a relationship for final length of any sub object. For final length of any object. Sorry, final. Prepare a relationship for final area of any object. Final area of object. Prepare a relationship for final area of object. Okay, now if you get the final area same. If I got the A2 is the final area, then A2 equal A1 plus delta A, no? Delta A same as previous. The L2 equal L1 plus delta L. The A2 equal A1 plus delta A. Now the A1 is keep here. Instead of delta A, I'm going to substitute A1 beta delta theta. Now A1 we can get out 1 plus beta delta theta. This is A2. This is A2. Now you have another equation for the A2. Okay, note down that that's only you have in the area expansion. Okay. Okay, that's the area expansion. Only the difference is L change in linear expansion we got with L change into A and alpha change into beta. That's only. Okay, alpha is the linear expansion coefficient, beta is the area expansion coefficient. Okay. Area expansion in class activities. Question number 1. I can give you 2.5 minutes for the first question. Okay, now you have practice. Okay, you can start. The radius of a circular steel plate is 14 centimeter. Its temperature is increased from 50 Celsius into 150 Celsius. The alpha is given, the area linear expansion coefficient given. The calculate the area expansion of the circular plate in the given temperature. Okay, first question only I'm asking. Only first question. First part. If you got the first part, it is easy to get second part. Okay, time enough. 3 minutes. Only one answer. What happened to others? Only 2, 3. Kabir, uh, this type expansion questions not compulsory to convert into standard unit, because if you substitute in centimeter, the answer also comes in centimeter. Then if you convert it, the value is 0.0000, it is cannot understand. Then in this type MCQ question mostly come in, then you have to, in MCQ questions you have to substitute according to the question given answers, according to answers. Okay, others you can try. I can give you more 30 seconds. Good, 24 answers. The radius of a circular plate is 14 centimeter. Okay, before that, the question not given the circular plate, no? The radius is given. Then you can count the, you can calculate the initial area. The initial area is, you can calculate the initial area A1 equal the 5r square. 5r square. 5 mean 22 over 7. R is 14 into 14. 14 into 14, you don't need to, not compulsory to convert into meter. Then 2. What's the value? 22 into 2 into 44. 44 into 14. 44 into 14. 44 into 14. What's the value? 660. 660 centimeter square. Square centimeters. Okay, now you can substitute to the equation. The L1, sorry, delta A equal A1 beta delta theta. Now the A1 I got 616 square centimeter. The beta, the question given alpha, then how you convert into beta? By multiplying by 2. Then 1.2 into 2, 2.4. 2.4. 2.4 into 10 to the power minus 5 per Kelvin. Then multiply by temperature difference is 100, no? 100 Kelvin. Then Kelvin to Kelvin minus 1 cancel out. 616 into 2.5 is it? Yeah. Multiply by 10 to the power minus 5. 10 to the power minus 5. Signal problem in my side? Sanura? Is it in my side? Ah, okay. Okay, wait, I will change the router. Kabir, is there any problem with? Not clear? Wait. Yeah, I refresh the router. I think now it will okay. Now okay, no? Fatima, now okay? Is it readable? Good. Okay, then the value is 10 to the power minus 5. Then you can come for backward. Then it is 1, 2, 3, 4, 5. 1.47 centimeter is the answer. 1.47 centimeter. No? 1.47. Oh, if you 1.4784. 1.4784 centimeter. Correct? Very good. Amina, I got the answer. Great. Okay, now, okay, question number 2. What is the area of the steel plate when it is at 150 Celsius? At 150 Celsius mean what? What is the temperature? Final temperature. At final temperature, the question asks what is the area? Okay, what is area? Now, do you need any calculation? Do you need any calculation for this? Okay, send answers. No need any calculation now. Delta A you already got. Now the question asks A2. A2 means final temperature at 150 Celsius, the area. A2. Yeah, send answers. I can give 30 seconds. Very good. Amina, what's the answer? Dihini, what's the answer? Rehlan? Udani? Sandra, what's the answer? Very good. 670. Now the A2 is asking. I'll write here. The A2 is asking the A2 equal A1 plus delta A. Delta A. Delta A. Now the A1 is, we found it is 616. 616 centimeter square is the A1. The delta A is increasing length. So the increasing area 1.47 1.4784. 1.4784. Now the value is 616.4784. No, 6 not 16, 17. No. It is 1.17 square centimeters. Okay, this is the answer for second one. This is the answer for second one. Okay, now okay, the second question for homework. Second question for homework. Third question, I can give you 2 minutes. No, I can give you 3 minutes. Please calculate the third question. Okay, second question homework. Okay. Get the temperature. Final temperature is asking. Get the temperature and send me answers. It's a different kind of question using same equations, but now you can do this type question. You have 3 minutes. Now 2 minutes and 15 seconds you have. Quickly get values and send. Okay, time. Zero 0.17, like small temperature. Some question you need to understand first. The temperature of a triangle shape, the initial temperature is 28. Okay, its area is at 28 Celsius, it is given. This is the area. That is A1 actually. A1. Due to the addition of the heat, the new area, the addition of the heat, no, then your value is more than, must be more than this value. Addition of the heat, the new area is given. What is the new temperature of the object? Now correct, I think. Temperature difference is 0.17. Correct, correct. But the question not asking temperature difference. Kabir, what is the per Kelvin? The temperature value asking. Writes per Kelvin. Per Kelvin coming for area expansion coefficient. Okay, now understand very well. Very good. It is Celsius. Okay, now there is a triangle shape, whatever plate, aluminium or whatever plate, its initial surface area is A1 is 28, no? 120 centimeter, 120 centimeter squared. This is A1. Due to temperature increase, its area increase up to A2, increase up to 120.001 centimeter. 001 centimeter square. 001 centimeter square. Okay, this is centimeter square. A small amount is increasing. Now the theta 1 is given, it is 28 Celsius. This temperature is given 28 Celsius. This temperature is, we don't know. Theta 2, we don't know. And it is given, the alpha value is given. There is a problem here. The alpha is not given. Have you got these values without alpha? Yeah, there is a mistake. Yeah, previous questions, no? Yeah. Without alpha value, you can't do this question. Okay, then you have to let me know. Then aluminium alpha value, I think given, no? Aluminium alpha value, sorry, that's my mistake. steel is given. Aluminium 20 into 10 to the power minus 6. 20 into 10 to the power minus 6. 20 into 10 to the power minus 6. Very sorry. 20 into 10 to the power minus 6 per Kelvin is the alpha value. This is alpha, okay, not the beta. Now you can convert into multiply by 2 and convert into to 40. Okay, 40 into 10 to the power minus 1. Then the alpha value is given. The alpha is 20 into 10 to the power minus 5, no? 6, 6, minus 6. Then the beta equal 40 into 10 to the power minus 6 per Kelvin. Okay, now every data you have, everything is given. Now how you get the delta L equal L1, not L A. Delta A equal A1 beat delta T2. Delta A. The A1 is given 120 square centimeter. The delta A also we can get A2 minus A1. That is 0.001 centimeter square. The beta given 40 into 10 to the power minus 6 per Kelvin. Now the temperature difference. We don't know what is the temperature difference. Therefore, you can say it is delta theta. It is delta theta. Okay, now centimeter square cancel out. 0.001 equal 120 into 40. 120 into 40, 12 into 4, it is 48. 4820 into 10 to the power minus 6 into delta theta. Now I just want to isolate the delta theta. Therefore, delta theta equal 0.001 divided by 4800 into 10 to the power minus 6. Okay, can you get this value? This is the temperature difference. But the question not asking temperature difference, you just can find the temperature difference. Okay, you can use calculators. Quickly get the value. It is 0.2, no? 0.21. Okay. But this question always giving this value. You need to get the question given value, Habib. We need to use sometimes they are approximate values given, but you want to use question given value. By mistaken, I have missed this value. Okay, Kabir. You need to use the question given value. This value always question given. Okay, therefore you don't need to worry. Now it is 0.12, no? The temperature difference 0.21. 0.21, yes, approximately 0.21 to 1 Celsius. Okay, it is temperature difference, but the question asks the theta 2, then it should increase, no? It should increase, then the theta 2 equal 28.21 Celsius. 28.21 Celsius is the answer. Yes, Sanura correct. Kabir understood? If in doubt, please ask. We're doing same equation, different type of calculations. Fatima, are you good? Amina, Udanya? Dihini, you got no? Rehlan? Dihini, are you good? And what else? Sarmya? Okay, good. Okay, now other questions you can do in home, and if you want, I will send answers into the group. You can check with these answers. Okay, you can try. Okay, now we move into our volume expansion. Volume expansion. Can we get more 10 minutes? I will just explain the volume expansion and complete the expansion. Then we can do next week few calculation and complete the expansion part. And we going to very interesting quantity of heat part. Can we get more 10 minutes? Okay, we can. Okay. The volume expansion. The volume expansion. Actually, now I don't need to explain this. You can imagine everything. The volume expansion means delta V. The volume difference, delta V. Okay. Then think in volume, the main thing is we mainly consider about three dimensions like this. 3-dimension objects. Okay, 3-dimension object. Okay, this samely for volume expansion, there are three main factors affecting this. First one is the initial volume. Initial volume. The initial volume is V1. The second one is the temperature difference. Same as last two, linear and area expansion. The temperature difference is delta theta. Third one is the matter type. Okay, when increase the initial volume, the delta V is increasing. Therefore, the delta V directly proportional to the V1. Okay, that's same as previous. Samely, the delta V directly proportional to the temperature difference. Temperature difference increase, delta V increasing. Therefore, we can get equation that delta V equal directly proportional V1 delta theta. To remove this proportional mark, we need to add a constant delta V equal V1. Now it is gamma. Remember, new symbol is coming. It is alpha opposite side. Alpha. It is alpha. Alpha. Now it is, this is a gamma. This is a gamma. This is a gamma. Then gamma delta theta. Now the gamma is the volume expansion coefficient. The gamma is the coefficient of volume expansion. The volume expansion coefficient. Volume expansion coefficient. Okay, quickly write down the note. Write down the topic volume expansion. Write down first point. When increase the temperature of any substance, when increase the temperature of any substance, when increase the temperature of any substance, the volume increasing, the volume increasing from three dimensions, from three dimensions, from three dimensions. Write down within bracket length into width into height. 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 When increasing the temperature, the volume increasing from three dimensions, close the bracket, is called as the volume expansion. Is called as the volume expansion. Is called as the volume expansion. Is called as a volume expansion. Right, and second point, there are three main factors affect on the volume expansion. There are three main factors affect on the volume expansion. Okay, write down first one, initial volume V1, temperature difference delta theta, third one matter type or substance type. Substance type. Matter type. Okay, now draw a small figure. Draw a small figure like this. Draw a small figure like this. This is V1, V1, V2, and if you can mark increasing, how it is increasing the volume in three dimensions now. Three dimensions increasing the volume that we called as the delta V. That's the delta V. Okay, you can make a small diagram and write down these relationships. And finally, label the volume expansion coefficient. Label the volume expansion coefficient. Finally, label the volume expansion coefficient. Complete. Complete. Fatima, Amina. Finally, label the gamma is the volume expansion coefficient. Okay. Now write down the topic volume expansion coefficient within bracket gamma. Write down topic volume expansion coefficient within bracket gamma. Write down topic volume expansion coefficient within bracket gamma. Khabi complete. Volume expansion coefficient within bracket gamma. Quickly write down. Here we don't have time. Okay, good. Volume expansion coefficient within bracket gamma. Write down. The gamma is a constant. It's depend on the material type. The gamma is a constant. It's depend on the material type. The gamma is a constant. It's depend on the material type. The gamma is a constant. It's depend on the material type. It's depend on the material type. Okay, see this. Samely, we can define the gamma as same as previous. We can define the gamma by this method. Now I can isolate the gamma. The gamma equal delta V over V1 delta theta. Now we can define the gamma when increase the temperature by 1 degree of unit volume of any matter. The amount of volume increasing, that we called as a gamma, volume expansion coefficient. It's also the unit is per Kelvin, because cubic meter into Kelvin, it is cancel out. It's also per Kelvin. The unit standard unit is per Kelvin. The other very important factor is the gamma equal 3 alpha. The gamma is 3 times than alpha. The gamma is 3 times than alpha. Remember. Okay, write down. Second point with the star mark. Second point with the star mark. When increase the temperature by 1 degree of, of unit volume of any substance, the amount of volume increasing, called as the volume expansion coefficient. The amount of volume increasing called as the volume expansion coefficient, called as a volume expansion coefficient. Okay, quickly write down this part. Complete. Okay, now write down with the star mark. The gamma is 3 times than the linear expansion coefficient. The gamma is 3 times than the linear expansion coefficient, and write down gamma equal 3 alpha and highlight this. Gamma equal 3 alpha and highlight this. Gamma equal 3 alpha and highlight this. Gamma equal 3 alpha and highlight. Are you tired? Only one topic. Final subtopic. Prepare a relationship for final area. 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 Now you already know. The final area is how we get the final area? The V2, the final area means V2 equal V1 plus delta V. V2 equal V1 plus V1 alpha, V1 gamma delta theta. Now V2 equal, get V1 out, 1 plus gamma delta theta. Highlight this and write down. Write down only this part. Okay. Okay, do we have, this is the volume expansion. In volume expansion also we doing few calculation in next day. Okay, volume expansion few calculation we can do in next day. And next, the theory part of solid expansion is completing, and liquid and gas expansion is a small part that we can discuss within 20 to 30 minutes next week. And the half of after 1 hour of next week class, we start the very important, the second part. Don't miss any part because it's going as a series, same as this. The second part also, the quantity of heat part also like a series. Therefore, don't miss any part. If you missed any part with connection error or whatever problem, you can go with our website. You can go to the page. You can get the recording. Okay, you can get the recording. Please in touch with group announcement and website announcement and website updates. Okay, okay, work hard because you have only 12 months to the exam. Now you have to work. Okay, this day-to-day works, try to complete within the same week, then you can manage your time very well at the final month. Okay, now you have, this week you have homework. This week you have homework. For volume expansion also, I have given few questions. You can try. That we can discuss in the next week. Okay, other I given questions compulsory. Linear expansion and area expansion homework questions compulsory. Okay, any doubt from today part? Any doubt? Any doubt? No. Then great. We meet next week with the quantity of heat and work on this. Work on the worksheet and what else? We meet next week with the new part of the heat lesson. And tomorrow 27 class, if anyone come to 27 class, tomorrow we doing this second part of the moment of force advanced calculation. Therefore don't miss if you come into 27 class. Okay, that's all for today. Yeah, good night.